Okay, so a scatter plot is basically just a fancy way of saying it's a graph. Right? But it's going to be a special kind of graph. So a scatter plot is going to be a graph that shows a specific relationship. Now, what are we talking about by a relationship? We're talking about things that would go together. So it shows a relationship between two sets of data. You can basically do this to anything. So, for instance, we could have the number of free throws shot compared to the number of free throws made, right? And whatever it happens to be. We could have, like football right now, you could have the number of rushing yards per attempt, or the number of, so you can make some kind of thing, and normally now my scatter plot's going to go up or down, and it's going to be pretty consistent. May not be. So now, do you know what I'm seeing by a set of data? This is kind of one of those things that we would have talked about a little bit more than the other thing. But anytime that you hear sets, they're going to be written in these funky little brackets. So if you can't draw these ones, that's okay. Don't freak out about it. Just draw little brackets around it. But each one of them would have a set of ordered pairs in them. So they would show, 2, 3, 4, 6, 6, 9, and so on and so forth. So this would be one set of ordered pairs, and then they'd have to give you a whole nother set underneath it. And you would plot them, and you would see what happens. When you do this now, you can basically make up what you want to be your X and what you want to be your Y. You just have to be consistent between your two things. Don't switch them when you're talking about it. Right? So if you're talking about free throws made compared to the free throws attempted, either one could be the X. Either one could be the Y. All right? Doesn't really matter. The most important thing, though, is that after you get your two sets, and again, so we would have to have another set here, and again, they would give us 3 more things or whatever, and we'd say 1, 3, 2, 6, 3, 10. So that's my other set. But when you do this, make sure that you label your axes. What do I mean by labeling the axis? No. I already know that it's my x-axis and my y-axis. Again, which one's this? X. This is my x and this is my y. So when you're doing scatter plots, they're all going to pretty much be in this, what was this quadrant? 1. And what's true about all the points in quadrant 1? They're all positive, right? Doesn't matter what coordinate it is. If it's the x or the y, see how they're all positive in that? So they're all going to be going up like this, or all going to be coming down. But a label means we would put something down here. So free throws attempted. And then free throws made. But I want everybody to know what my graph or my plot is trying to show. Okay? So will you turn your book to page 41, please? So as you can see here on page 41, this is a lot easier in the book than trying to explain this, drawing it out. You have 3 ways basically to interpret a scatter plot. This would be on the top of page 41. So what were those three ways? What does it say up there?
Positive relationship.
Yep. So a positive relationship. And if I have a positive relationship, where are my dots going? Up, basically, right? So in our first quadrant, they would all be going up this way, right? And it's a positive. So again, hopefully, now do the free throws made and the free throws attempted, would that necessarily be true all the time? Well, you would hope that you would get better, making more as you attempted more. But it might not always come true, right? So what's another way? We could have a negative one. And if we have a negative result, what happens? Where does my graph go? But up here, top left to bottom right? But we're still all in those same quadrant one, because right now we're just talking about all positive points. Okay? And then the last one is what? There's really none. There's no relationship or there's none. So this just means that you would have random dots. Or random points. So again, on page 41 there, they give you a good, but you might not, when you draw this up arrow here, you might not actually hit any points on your graph. Okay? But in general, it's going that way, and the same thing happens here. Okay? So you might not hit any of the points, but you still have a positive relationship or a negative relationship. And then the random one is just all over the place. Okay? So, if you saw this now, it says, or you can't see this one, I don't think, in your book. But here's my table. So, I have a year, and then I have cents. And then my second one is year and cents also. And then they give me information. So this is 1920, 30, 40, and 50. And this is how much a loaf of bread costs. So we're going to show you what the loaf of bread was. So in 1920 it was 12, went down to 9 cents, and then 8 cents, and then 14 cents, and then it went all the way to 20 cents in 1960. Okay? And then if we continued it down here, 1970, 80, how far are we going? 90, and then 2000. Okay? In 1970, it was 24, 52, 72, and 99. So, if you did this now and plotted this data on a coordinate plane, do I really want to make each of these things and count out for all of the years? Probably not. So when I start making my graph here, I might make this into 1900 right here. And then instead of having 2, 4, 6, 8 or 1, 2, 3, 4, I'm going to adjust my information to my graph. So this was 1910, 20, 30, 40, and so on and so forth, right? So I don't always have to use 1s or even 2s or 5s on my graph. But just be consistent when you make it and you put numbers on your graph. Be consistent. Okay? So what would we do going up on my y-axis? For my cost, what would you probably change the numbers to going up? What do you think? What can I fit all of this into? By going up or down by a certain number of cents in this case. What do you want to use for your plots? Going up 10 maybe, right? So we start at 0, here's 10, 20, 30, 40, 50, 60, 70, 80, 90, $1, right? We never get to $1, okay? So, remember, this is all cents. So then we'd come back and we would plot all these things. So how do I plot the first one? That in 1920, it was 12 cents. Where would I go?
Over to the 20.
Go to 1920,
Yeah.
and then what?
Up to,
Up to 12, right? Now here's where you gotta be careful because we didn't probably make it big enough, so we're kind of guesstimating where that 12 is. And then we'd go through and put the rest of it, right? Here's 30, now we're back under the line. 40, we got a little lower. But then in 50, we went back up to 14. 60, we went to 20 cents. And then I'm going to jump all the way to 60, 70, 80, 90, 2000. And in 2000, we had what? Almost $1. Okay? So here's the question. Why did this happen? If you looked at it and we filled out the rest of it, we would have had a 72 cent right about here. And then we would have had 52 cents in 80. But why did this happen? Why did we start here and go down around the 30s and the 40s? The Great Depression, right? The Great Depression. And so it went down, and then gradually it went back up, right? So here, if we asked you what was our scatter plot showing, down here in this little section right here, we would have said it was a what? A negative, right? It was a negative relationship. But then after that, even though that if I drew a line right here, maybe I hit one dot, but what would you say in the long run for those 60 some odd years, what happened? It was a positive increase. Now, is this a true positive? Well, it definitely went up, but is it a positive for us? Well, the bread kept getting more expensive. So even though that it says that it's a positive relationship, it doesn't always mean that it's a positive in our eyes. And not all negative things are bad, are they? I mean, if we had a negative where our electric bill kept going down, we would like that one, right? So there was a negative relationship, but maybe we didn't run any air conditioning or a heater. So like right now, right? Maybe you don't use as much air conditioning and heating, so your electric bill is going down from what it was this summer. Because this summer it was really hot sometimes, right? And then when we got back to January, so in some relations, your graph could go up and down more than once, and it could vary. But then you would have to think about, well, why is that, okay? If it's free throw percentage again, maybe he closed his eyes for a week to prove a point. I don't know. Maybe with the bread, maybe we went through a pandemic. So when the slaughterhouses and stuff got shut down, you know, the price of pork went up because we didn't have any pigs to slaughter. Maybe that's what happened, okay? So what we're trying to get at here is we want to understand what our graph is saying, right? And usually when we say this, if it's positive, again, the X and the Y's are both going up. If it's negative, my X and Y's are both going down. And then if it's random, we just don't really know what's happening. It's kind of chaos, okay? And we would just have a bunch of points all over the place. So, if we look back in our book, okay? Turn the page. We're going to look at number 4 in the book, page 42. Everybody see it? So we want to determine whether a scatter plot of data for the following might show. So just think about this. We're not going to actually make a scatter plot, but we're going to decide if it's going to show a positive, a negative, or no relationship. But again, we're thinking about positive and negative in the respect to what the graph is going to show us. So even if it's a positive, it could be showing a positive, but we might actually think it's negative. But we're actually answering it with respect to the graph. Okay, so what relationship would you say the hours that you work and how much you make are? What would you say? Would that be here? If I work more hours, does my pay go up that I get at the end of the week? Or would it be negative, or would it be random? It should probably be positive. And in this case, it's positive, right? Because that's a good thing for us. Yeah, we might have to be away from home a little bit more, but we're bringing in the bank at the end, right? Okay, I agree. Next one. Your hair color and your height. Does your hair color tell you how tall you're going to be?
No.
Is there any relationship that would say that? Heck no, right? So which one would we say for that? That's none. Okay? It doesn't mean that all blonde people are 6'5". Okay? Just doesn't mean. So we would just have nothing. Over to the right. For 6 and 7. Do you see what I'm talking about? They show a bunch of people's names, and then they measured everybody, and then they show their GPA. So here again, if I knew everybody's height in here, would that automatically tell me what their GPA is going to be? And is there a relationship between smart people being tall or smart people being short? No. So in this one, there's probably no relationship because it doesn't mean anything. So that's what you're going to do for your assignment. You're going to decide in the middle, what kind of relationship do I have? So like if you go back to the example right above this, okay, they're talking about the lengths and weights of a bass. Okay? So if you had a longer fish, would you expect that it'd be heavier? Sometimes maybe not. Depends on maybe what kind of fish it is. Okay? But in theirs, what happened? The longer that it got, what happened? The more weight it was. So if we would continue this on, and I told you that I caught a 25-incher, what would you probably say the weight was? Roughly.
6 pounds.
Maybe 6 pounds, right? Everybody see what I'm saying there? So then under 9 inches, we could actually have one that's barely even there. So it could be 8 inches, and it could be so skinny that you wouldn't even know that you actually caught it. Right? But that's what you would kind of use the scatter plots for. Right? So it's kind of a simple process, and this is more about interpretation than it really is anything. So don't freak out about making your graphs exactly right. You're just kind of seeing, do my points go up or do my points go down? Okay? Questions here?